So in this example, I'd like to illustrate how we can actually use regression results to make better business decisions. Well, so far you've seen from the other work examples as well as the practice problems and homework and also the assignments. You've probably seen that how easy it is to actually perform regression using stat tools. Stat tools is great. It actually really minimizes the process that you have to go through in order to create regression, even with like nonlinear transformation or dummy variables and all that complication. You can still do a regression rather quickly, and then you can get the results along with all the estimation characteristics such as R squared, just the R squared, standard errors, and all that. So the regression itself, performing regression itself, is a relatively simple process. The difficulty or the important thing is really how to interpret the regression results and also how to use regression results for business. And hopefully this example will illustrate that. So this one is problem number 63 in chapter 10 of the textbook on page 468. And the file is P10_63, and you should pull that up. And once you pull that up, you see the file right here. So this is a record of 70, I believe. No, it's 90 motels. So this company collected the data about 90 motels, and with the for each motel, there's some factors or there's some there's just some parameters associated with each motel is also collected. So for instance, whether this motel has indoor pool or not, and how many competitor rooms are in the same region, the distance to competitor, the distance to the closest competitor, what is the office space in this area, what is the median income of people in this area, and also the distance to downtown of this hotel. So all of these are factors associated with a motel, with each property. And of course, the last column, the operating margin, is the performance of this motel. So we want to see whether there's any relationship that we can actually create between the operating margin and any of these factors. So maybe there's something that we can see. So all of these numbers will actually explain whether the operating margin is low or high. Okay, so that's one thing that we really want to know from this data set. But this is not just an academic exercise, because the reason that we want to do this is because we can actually use the result to make decision on, say, the future expansion. So on the second spreadsheet is this company has already found 5 potential sites. Okay, so for each site, the company has gone out to explore the numbers or the estimates for each of the parameters. So for each site, they have discovered the number of competitor rooms, the distance to competitor, office space, median income, and the distance to downtown. So they want to see if there's any way that we can actually estimate the margin based on these factors, so that we can actually determine which site is the best for the next expansion. So this is actually a very common business exercise, right? So we have some data for the based on the existing performance or some past records, and then we want to use the data to see if we can actually paint a picture for better prediction or for better forecast, so we can make a good business decision based on what's already happened. So we want to summarize the data, create some kind of the pattern, so we can actually make a better business decision for the future. So this is where we can actually use regression for. So let's see how we can actually perform a regression and then create some kind of a prediction pattern so that we can actually use that to make a decision on the potential sites. So the first step is to do a regression, right? So let's do that. So stat tools is already installed. So we go to stat tools. We have to declare this data set. So do we want to add this as a new data set? Yes. Okay. So now the whole data set is included, and then we can create the regression. That's relatively easy, right? So go to regression, and then we have to use the operating margin as the dependent variable and everything else as the independent variable. Of course, the motel number should not be included, and then everything else is included. You should note that the indoor pool is a category variable because it has only two possible values, yes and no, right? So if you include a categorical variable, then the regression result will be presented as like two separate equations, one for each category, and then because there's no interaction, so you see that the essentially the two lines, or well, because there are too many variables, it's not a line, but all of the coefficients for other variables will be the same for these two regression equations, except for the intercept. The intercept will be different. So essentially, there are two parallel regression results. So I want to add the display regression equation is already added, so that's good. I'm going to click OK. Then the result comes up. So this is a little long. The equation is a little long, so I'll just use the top part. So the top part, so I can see that these are all the coefficients associated with each one. So the first one is, of course, the intercept. That's not that important because that's the value for margin for the margin if everything else is zero. So that shouldn't concern us at all. But we can look at each one and see whether they make sense or not. Well, they're all pretty small, but the total effect will be relatively large when you add all of them together, because if you can see that the operating margin is actually because it's all percentage. It's all percentages, right? So it's actually they're stacked really close to one another. So which means that even if you make small changes, then you make some small changes in any one of these factors, then the effect on the margin is only relatively small because it's already in percentages. But the first one is actually pretty important. So whether you have a pool, indoor pool or not, the operating margin changes by about 2%. So that's actually pretty significant. But other than that, everything else, because the numbers can be pretty large, so the effect, the coefficient is relatively small. So it's actually very hard to judge which one is more important just by looking at the absolute value, because the unit of change is very different going from one to another. So for example, the competitive room versus the median income. Median income is like every additional dollar, so that wouldn't make so the comparison between the coefficient of the competitive room and the coefficient of median income wouldn't make any sense because the unit of change is very different. But the sign probably tells a pretty good story. So whether there's indoor pool or not, that's pretty significant. So when you delete the pool, so actually this factor is no. So when you don't have a pool, then the operating margin drops by about 2%. So that's pretty significant. But the increased number of competitive rooms in this area actually will lower the margin, which makes sense. But however, if you're farther away from the competitor, the margin is a little lower. That probably doesn't make much sense. But in this case, once you include this, when you see that the R square is pretty large, then you think, okay, so maybe that's pretty good. So I'll just leave everything two way. You can actually, the other way to do that is actually you look at this and so see whether all of them make sense or not. If they don't, then you can just leave them out. So you can actually change the regression. So for instance, the distance to competitor, that probably doesn't make any sense. You can delete that in the next regression. The median income drops. So the median income actually has a negative effect on the operating margin. So if you don't think it makes sense, you can drop that. So you can do another regression, but I'm not going to do anything there. I'm just, because I think that the R square looks pretty good. Just the R square is very close to the R square. So which tells you that most of these independent variables probably have pretty significant effect on the operating margin. So I'm just going to leave everything in. Okay, so I have all that. So that's good enough. So what about so again, the R square is large enough. So if I include all of these factors, then 78% of the variation of the operating margin is explained by these factors. So that's fairly strong. So now so we created a regression. The next step is to use the regression result for the potential site. So how do we do that? Well, the easiest way is just to use the equation, right? So because now we can take the equation and then doing the calculation and figure out whether this will work out or not. So what do we do here? Well, we can actually, so in order to apply the equation, basically we just take the number of competitor room, multiply by this, and so on and so forth. So what we want to do here is just to take the go to the potential site, and then let's see the how we can calculate that. So basically, we want to take the competitor room multiplied by the coefficient of the competitor room plus, so that's that, plus the distance to competitor multiplied by the coefficient of distance to competitor, and so on and so forth. So that's all we have to do there. So how do we do that? Well, that's that looks like a pretty hard job, but we can actually do it rather quickly. So we just have to highlight this. Let's see, copy it. Okay, so we go to home and then copy, and then we go to the potential site, and then we're going to actually let me do this, and then just bear with me, and then you'll know why I do that. So I'm going to highlight this whole row, and I'm going to paste, but with a transpose. Okay, paste special, and I'm going to transpose it. So now I'm actually copying this way, right? So this tells me that each one of these. So the indoor pool, the coefficient for the competitor room is this. The coefficient for the distance to competitor is this, and so on and so forth. Okay, the only difference is the indoor pool. So what does that mean? Well, this indoor pool has the coefficient of that. So whether this is yes or no, and it depends on whether so you will determine the intercept, right? So the intercept is 61. So the intercept is for yes is this is 61 point is 0.6158, and the intercept for no is that. Okay, so I'm actually going to create another because there's no record for indoor pool, so I'm just going to leave that out. But let's say that I'm assuming that everybody has an indoor pool because there's nothing here, right, for that. So I'm going to start with the intercept with indoor pool, and then I'm going to calculate the operating the estimated margin using all these factors. So how do I do that? Well, I'm just going to do this one, right? So this is the coefficient or the intercept for a motel with indoor pool. So let's assume that there's indoor pool, And then I'm going to add all of these. So I'm going to add the sum product of this and that. So I'm going to do the sum product of this part, right? And then all the coefficients. But of course, the coefficients have to be absolute value. Okay? So now I can calculate that's the margin for this. So you see that? So the A9 is the effect of is the intercept for motels with indoor pool, and the rest is to use all the coefficient, the regression result, to predict or to find the fitted value of the operating margin. Okay, so because the way that I constructed this, I can just copy it all the way down because the coefficients have the absolute value, have the absolute reference, and the rest are relative. So I'm just going to copy it down. So obviously there's something wrong. Oh, that's here because at this one I have to do absolute value too. Sorry. Then let me correct that. Copy it down. So you see that now I've calculated the estimated margin for each one of these. So actually, if I want to pick the estimated the potential site with the highest potential margin, I would pick this one, right? So site number 4 because the estimated margin is 51%. But number 1 and number 3, they're not far behind. It's actually pretty hard to say that 51.1 is definitely better than 50.47 because there's still a lot of the errors. Remember, the R square is only like 78%, so not 100% of the operating margin is explained by all these factors. So I would say that site 1, 3, and 4, they're all very good, but I would not pick site 2 certainly, and I probably won't pick site 5 because that's pretty far from the better ones. Of course, unfortunately, we don't have this data because this is not independent data. We can decide later whether we want to build indoor pool or not. But based on the two different regression equations, when we include the indoor pool as the dummy variable, then we see that adding an indoor pool will add about 2.2% of the margin. So this is not part of the decision in picking sites. But if you want to maximize the margin, you probably want to include indoor pool. So you just make an assumption of with or without indoor pool for every one of them, so that you can compare the estimated margin based on the objective numbers alone, so that you can pick the best ones, which are 1, 3, site 1, site 3, or site 4. Okay, so this example shows how you may be able to use a regression to make predictions and make better business decisions. And this is exactly how most of the data analytics method work in business. That is that you try to find certain relationships and then you use the resultant relationship to make some predictions, so that when you have to make a decision for your business, then you can make more informed decisions. And hopefully this example shows you that how this can be done.